I will say, it is almost certainly the worst quantum magnetometer on the planet. But it is a quantum magnetometer. We have checked it in, now several labs have checked that it works, and the theory is very solid.
I think a lot of these things are opaque, and I think that's the beauty of doing a sort of DIY device where you can then figure it out. And then, once you're convinced, you can go and buy the flashy one from the latest, unicorn quantum company.
If you're tuning in as this episode comes out, Defcon 34 is just a couple weeks away in Las Vegas. And for the 5th year in a row, Quantum Village will be bringing the magic of our field to the world's largest hacker convention, complete with 2 open source devices that you can build at home. Find out how to participate and what I'll be talking about on stage in this episode of the Post-Quantum World. I'm your host, Konstantinos Karagiannis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Our guests today are longtime friends of mine, frequent guests on the show. They're the founders of the Quantum Village, Mark Carney and Victoria Kumran. Welcome back.
Thank you very much for having us.
Hello. Great to be back.
This is a long time coming, 1 year, but yeah, it's a long time. I like to do this annual thing. And as we're talking right now, outside in New York City, there is yet another Blade Runner 2049 situation with orange skies from wildfires. I mean, this happens like every year now. And I was walking before and having a hard time breathing. And I'm like, don't worry, in a couple of weeks, you'll be in the desert where it's 110, but dry. So that's what's happening to me. So yes, we're all excited for Defcon. So now I'm going to put the impossible job on Mark's shoulders, which I love to do every year. If you're a new listener, get ready for this annual tradition where Mark tries to explain in a brief answer what Defcon is.
What is Defcon? Well, it's cancelled this year, so we all have to just finish there, I think. Okay, so Defcon, I think, is one of the largest hacking conventions in the world. Certainly one of the largest in the US. It is where roughly 30,000 hackers, technologists, makers, breakers, and pursuers of interest turn up in Las Vegas every year. And all there is to do is talk about tech and go to parties. So kind of what we do is we get together. Victoria and I have both been going to Defcon for many years. Yourself as well, Konstantinos. We're all old hands here. It's difficult to encapsulate it in a sentence if you haven't been. But realistically, it's where a lot of people go to learn about technology usually from the people who are doing it or for the people who are having to manage it or work with it or secure it. And it's a place where you really do find that kind of creative misuse happening, people doing unusual things with technology and using it in ways that were never intended. So that's, I think, a reasonable encapsulation.
Yeah, that captures it. And it grew a lot. I mean, as you said, 30,000 people. Now it's in the Las Vegas Convention Center, which is probably the biggest thing that was ever made by humankind, probably bigger than the Great Wall of China. I mean, when you're in it,
it's like the conference capital of America, really.
Yeah, I mean, I still can't believe how big. I'm in New York City, and I'm in awe of how big that building is. And of course, Defcon has villages, these focused areas of technology types, and I think the first one was like the Wi-Fi village, and now we're, of course, in the 5th year of the Quantum Village, which is what you guys do. And so congrats on that,
Thank you.
Stuff. And Victoria, tell me some of the things that have changed in Quantum Village over these 5 years. Like, what's your current level of achievement as organization status? What have you become?
I mean, I think the good thing is, I think when we first did it, there was a sort of hodgepodge mix of, this again, is this just more snake oil? We're always sort of 10 years away to, are you detecting alien life forms? Which actually is possibly a use case, quite in all seriousness. But, in reality, we've really evolved over the years from, I think, getting from the sort of entry level stuff to seeing how outside of, say, Defcon even, how much the quantum landscape is it kind of exploding with, companies listing and so on, and a lot of government action across the world. So I think now we are getting, I think, people who are not, it's not necessarily their first time starting it. So we've been running the quantum CTF, the quantum capture the flag that we've done. And I think what's really nice is each year it's been evolving in the complexity of the kind of challenges we've got. And we're now also doing sort of hands-on technology that we're building ourselves and doing sort of open source demos, such as the open source quantum sensor we released last year. And this year we're going to have a QRNG. And really it's there to kind of help build that intuition and show that people can actually sort of build these technologies today. It's not going to be the exquisite quantum computing machines that are going into data centers and whatever, but it's really helping people understand that it's real, it's something you can touch and something you can feel. And I think it's only with that do then people start realizing that they can kind of have access and participation inside it.
And before I ask you one more question about the current status of the village, there was an infamous situation a few months ago where a podcaster failed to ask former President Obama when he brought up aliens. He forgot to ask a follow-up question and everyone destroyed him on the internet. So because you mentioned alien signals, I feel like I'm legally required to ask you, is there going to actually be a talk in Quantum Village about detecting alien life or alien signals using a quantum computer?
You know, I will say, given how advanced we are, we actually have had Dr. David Benoit do this for a B-Sides London. So we do deliver around the globe, and you know, we'll see if we can get him over this summer, and if not, another one. But there's definitely, and we could probably post it in the show notes. I think I saw recently there was another scientist in the US who's been looking at it. I don't know, Mark, if you've seen anything else, but certainly with quantum sensors as well.
I haven't, but it is actually a really interesting use case, right? Because you're building some of the most exquisite machines. Aside from trying to make intelligent machines, when it comes to computation and metrization and measuring and doing things, like quantum technologies really does open up some of the most incredible engineering. And what we want to do is get more people engaged in that. And if that is through talking about how we can detect aliens, then that is absolutely a route we will take. So we've already had it once. We'll do it again. It's on our pinboard as an actual theme.
Yeah, why not? I mean, there was the whole diversion with people thinking that quantum was being used to detect a human heartbeat from miles away recently in a military
application. Yeah, heartbeat means a different thing sometimes in different settings.
What's more easy to detect, an alien or that? Yeah. So, okay, great. So you guys received a certain boost from Mozilla, right?
Yes. The exciting update is that we've had our first ever sort of philanthropic support for Quantum Village. Being a non-profit, this was a huge win for us and a real sort of vote of confidence in terms of our community and looking at the communities of the hacker communities, the creator communities, and the ones that aren't necessarily in the sort of academic spheres. And that's really to support a lot of work we're doing with open devices, with the Uncut Gem platform, which has actually, recently been picked up by a lot of educators, which was something that sort of took us by surprise a little bit when we were setting out to do it. And it's being built into sort of quantum engineering programs across the US and Europe, which is really, really like a vote of confidence as well in terms of getting that feedback as well. And what's nice, I think, with Mozilla is they really understand that this is like a kind of opportunity space for, the security communities and the artistic communities that I think don't always get identified earlier enough is what I'd like to say, because I really truly believe that, as I've probably harped on previous episodes, that people in the security community have so much to give and so much to add when we're designing new systems.
Yeah, and both you guys did a great job last year on the main stage talking about Uncut Gem. And I guess I'll turn over to Mark if you want to give a little recap of both what that talk showed the world and how it's grown since then, the device.
So what it showed is that for around a modest investment of just a few $100 plus diamond, you could do very basic quantum magnetometry, so optically pumped magnetic detection, by building some circuits, putting together some parts, and writing some nifty firmware that allows you to actually manipulate this reasonably well-known Hamiltonian within nitrogen vacancy center diamond lattices. And so what we did with that is we open sourced completely the control plane. So if you are not a radio engineer, but you want to tinker with some firmware, you can just, deal with the part that you want to, so that all of the parts you need to actually do very basic magnetometry are on this board. I will say, it is almost certainly the worst quantum magnetometer on the planet, but it is a quantum magnetometer. We have checked it in, now several labs have checked that it works, and the theory is very solid, but the idea wasn't to build the best sensor yet. The theory was actually, can we build this from parts that we already understand from telecoms, for example? So we use a microwave generator. That's something that we have brought in from standard parts used actually in telecoms. We also made the decision to use green LEDs at the right frequency. We love a laser. Everyone loves a good laser. However, they are somewhat of an OSHA nightmare, I think is the way it was phrased to me. So with that, we decided to use LEDs, and it's amazing. Quite a few people push back on that, go, no, you need a laser. You don't need a laser. You want a laser. It's obviously better with a laser. But actually, if you do that work with just an LED, it can work. We also use, we don't use dichroic mirrors. We use just red filter gel. There's a paper from 23 that shows that actually this is 80% as effective as a dichroic mirror. And so the opportunity we wanted to present was, look, here's a bare bones version of this technology. Anything you do to it will make it better. But the point is that all the parts are there, and here is how you build it, here's how you fabricate it, and here's how you put it together, so that actually you can have a low-cost sensor that is utilized now in education. There are several quantum engineering courses that are using it. One educator told us, well, had it not been for a low-cost open-source platform, actually, our first supplier order might have wiped out the budget. Because when you buy from a university supplier, like, you're buying something that is designed for university lab usage. So it's very accurate, it's very stable, it's got all these amazing properties. So it was really nice to see that actually we're kind of wedging something into the space that I think shows you why open source might be a better option for certain parts of the quantum, certainly the quantum control infrastructure. And that really is, when I build an app for my phone, I don't build the whole phone. I just build the bit that I want to be concerned with. And I can do that because there's a lot of open source shared infrastructure. Mm-hmm. So we're asking that question as well, like more culturally perhaps, what is open source's role in quantum technologies, and how can we bring more people in to bring their expertise into an open source project?
It's really building on the shoulders of generous giants. I mean,
pretty much. And we want to keep doing this. The Mozilla grant that we've received is in a large part to push forward a more open quantum hardware. And this is what we've done this year. We're releasing a new device, as Victoria mentioned.
And who knows how many young future engineers you're going to inspire,
Absolutely. And also just how many people are going to become aware. Like, if it's something that's low cost, if you break it and you have to fix it, that's a learning curve itself. Whereas if you break the £1 million university lab equipment, lots of people start shouting at you and you're not allowed to touch it again. So I think that, there's this delicate balance between building something that's low cost, that is accessible, and then showing how you can have a broader ecosystem for quantum technology.
Yeah, I figure there'll be at least like 2 or 3 more Defcons before robots are able to be like, I just made it better.
At least one more Defcon this year, at least.
At least one more, yeah. We have a generous runway here to work with.
Hopefully we will be able to see them coming.
Yeah.
That's what the sensor's for.
And are you going to be doing anything else this year like that? Are you going to introduce any new devices, or?
We've got new devices coming along, and we're building out more on the Uncut Gem platform. And also just to point out that we always welcome more support. A lot with what Mozilla said to me was like, we're just helping you seed so you could go and get other philanthropic donors and other companies that in the ecosystem that definitely need the sort of workforce development as well, and the talent to come through. In terms of other events though as well, we are going to be popping up again at B-Sides Delaware, B-Sides London, and for the first time, I believe, B-Sides Cleveland, Ohio. So if anyone wants to see the new QRNG, it will be there floating around. And again, I think for us, it's another feat because it's really keeping at that low sort of $35 price point. And half the time, because it uses a Raspberry Pi Pico, you probably already have things at home that you might be able to use to get started. And I think that's the bit that, leaning on with what Mark was saying about telecoms, like it's a really great way for anyone from the telco sector to kind of start thinking, okay, maybe this like quantum technologies thing that I keep hearing about might be for me, because actually on these different levels around the engineering, that's where a lot of the work is needed right now to help build this exciting future that we've got ahead of us.
Yeah, to stay in the hardware space for a moment, the QRNG, you want to just talk a little bit about that and how does it work with, I'm assuming, some kind of open source application, and what can you do with it? Like what kind of output, what kind of duty cycle, like what can it actually generate practically?
Sure. So I'll give some details. So we call it the entropy loop because we're actually building, it uses loops of optical fiber. So the principle we're using is called a phase diffusion quantum random number generation, or phase diffusion quantum entropy. So there, we're not doing the very hard thing. There was a beautiful Hackaday article, I think, a few months ago, which talked about a really nicely engineered QRNG with the guy was using like laser pulses and was sort of using barriers to get it down to basically one photon and then two detectors with an FPGA. Really great open source engineering feat. A guy in Germany, I think it was. Really, really interesting. We wanted to go totally the other way. So what we're doing is something called phase diffusion. So there are quantum fluctuations that take place on every LED diode. So when you start up the diode, you will make a random determination about the particular phase. So the nice thing about lasers is every photon in, say, a cloud or a pulse of photons has exactly the same phase relative to each other. However, that phase relative to a different pulse is completely random. And those fluctuations being random come from vacuum fluctuations in the LED chamber itself. There's a very tiny cavity where the laser is generated in the silicon. So what we do is we build an optical network that allows you to amplify this. So we split the pulse of photons and then we delay some of it, and we have a firmware timed that the delay between each pulse is roughly the time it takes for light to go through the delay line, the actual optical fiber that's causing the delay. And then we bring them together, and so you're offsetting these pulses by one, which gives you random interference. And because they're all the same frequency, they will interfere, their phases will diffuse, and so that's where the name comes from. So you can get pure quantum randomness out of that system. And the nice thing is that a fairly straightforward calculation called min entropy is directly related to the randomness in that physical system. There's a paper by Carlos Abalan and company. He's the CEO of QSide. They came to Defcon last year, did an amazing demo of their technology, which is a very fast version of a very similar design. But he actually worked on this for his PhD. And this is something where it's very, very straightforward to understand. You can kind of get to the nub of what's going on very quickly, but also you can build it for about $35 worth of equipment. That said, it's not very fast. It's very slow, actually. And again, we might have built the worst quantum RNG, but it is fully open source. And like Victoria mentioned, about $35 of parts, which you can get from China. And the nice part is that, again, everything you do to it, if you know what you're doing or you work out what you need to do, everything you do to it is a decision and improvement that you know why you're making.
Yeah, things can only get better. And I think ultimately with what's been interesting doing the QRNG is actually like I sort of feel for people in the space, or certainly dealing around quantum security, but there's been this slight outrage, or I guess, there's apparently, and I'm fortunate being a non-profit, no one's trying that hard to sell to us. So I don't get all the vendor spiel, but it's certainly been that sort of, you're claiming that QRNG is PQC and all buzzword bingo. And ultimately, I'm going, what are you on about? It's more about just starting to get that intuition around what's going on with these quantum technologies. What are these effects? Like, you can actually measure the entropy, things like that. Then it's on to you as an engineer or as a designer or implementer in terms of what are your requirements for your systems. Does it make sense? Maybe it doesn't make any sense at all. Like, just because something's flashy and new does not mean that it's better. And we all, even myself, fall into that trap all the time, even when I've done other design projects and, 10, 20 years ago, I'm like, I want to use a 3D printer. And, actually sometimes it doesn't make sense. Today it probably does, but, it's all relative. And I think with the QRNG, it's more like, randomness is used in so many places like simulation, gaming, art, and so on. So it's really just helping to build participation in terms of like what is going on with quantum technologies and what is this randomness and how can we think about it? Because obviously we've had the Cloudflare wall with the what are those things called? I've forgotten. Lava lamps. What sin I've committed for forgetting that. But, things like that. But there is something in the sort of cultural psyche about it. So almost for us, whenever we're sort of doing a project, it's also thinking creatively about what does that mean in the sort of sequence of things going on in our culture.
It also lets us show why quantum RNG, because, TRNGs traditionally are two xenodiodes, say, or some other noise circuit, and they actually have a quantum start, but the difference is that you can't really measure that. You can't really attenuate that. You kind of trust that between one instance of doing, say, the NIST statistical test suite and the next time you run it, the system didn't change in the middle. The nice thing about a quantum system is it can tell you how quantum it is. You can measure how much you're getting phase diffusion. And so that's where you can monitor the quality of randomness. And so we've had a lot of people who've built the system actually have that learning curve. Oh, I get it now. Oh, I understand where the benefits are coming through of doing the quantum thing as opposed to just what I might have. And that, again, should hopefully feed into a broader understanding of quantum technologies and their values.
Yeah, and of course, these are never going to be a replacement for PQC. They're just a different thing. So
Yeah.
I hope
absolutely.
no one ever makes that mistake. They're definitely different. So the theme this year of Def Con is agency. Every year there's a theme. I don't believe I'm really addressing that in either one of my talks. Oh well, whatever. And I should point out I'm doing 2 this year because Victoria and Mark don't like me. They want me to have no sleep from now till DEF CON. So I'm doing 2. I'm doing one in the prayer stage and one in the village. So look out for that. Yeah. So how are you guys handling agency in your and explain what they mean by agency, of course.
I think for us, because last year was about access, and I'd love to comment on the access piece because we actually recently just got back from Geneva where it was around access as well. But I think building on that, and actually, the thing about agency, it's kind of how do you command it on your own terms? And I think we're all in this sort of, I'd be remiss not to mention AI, like where we feel like, we're just sort of feeding into the Borg a little bit, and I think taking back that control and that understanding. And I think a lot for us, building your own devices and even like building your own randomness source, historically has been cited as the thing that where, you actually can, that's the only one you should trust, where you can actually see what's going on. I'm not necessarily saying it has to be entropy loop or that's the one that's sufficient, but it's more about understanding the processes and systems around you, because I think a lot of these things are opaque. And I think that's the beauty of doing your sort of DIY device where you can then figure it out. And then, once you're convinced, you can go and buy the flashy one from the latest, unicorn quantum company or hyperscaler. But ultimately, it's really building that understanding, because then you can actually make those decisions for us anyway.
And Mark, you made a pretty excellent tool years ago, Cryptomon, right? And there have been other things since then, and now we've entered the world of vibe coding. Okay, it's here. I've been looking at some tools. I think every company should be installing a cryptographic posture management tool, of course, for sure. You should. But for PQC, some companies, like when I first talked to them, they want to do some like offline stuff, analyzing logs, things like that. So I whipped something up, of course, in Claude, like I'm sure other people have done, and it's been growing and growing, and I just got to thinking, like, how does that fit into all of Defcon going forward? You know, this idea of like releasing tools, all this sort of stuff. I mean, I know this is sort of unfair. This is outside the quantum village, like branches of Defcon. But how do you see it going? You know, if you're both welcome to weigh in. Like, if you were to put on your prediction caps, what do you think Defcon looks like in a year or two because of this? Like, is it just look what I vibe coded, you could do it too, or is it look what I vibe coded, downloaded? Like, what is it? You know, like, how's that going to look?
Well, there's the idea that gets floated a bit, which is that SAS is dead. I mean, everything's sort of has a timeline. I think. I mean, there's a very famous quote which basically says that the Stone Age did not end because we ran out of stones, right? And I think that we're not going to suddenly stop writing code and stop editing code and finding bugs in code. I mean, I've written it's over 1 million lines of code with an agent, and I found all sorts of bugs
Sure.
and issues and problems. And so is the agent itself. I think that Defcon is going to keep finding ways of working out how we can access technology. And this is why this theme of agency, I think, is actually really important, as well as last year's theme and the theme from the UN ITU event, Quantum for Good. Victoria was emceeing, I was doing one of the short keynotes, where we want to say, what is this technology if we do it for good? What is this technology if we have access to it? How do we utilize this in a way that we could be safe and secure and use it to enhance our lives, as opposed to, sort of just, feel indebted or oppressed by the AI LLM? And I think that's what Defcon really offers you, this ability to really look under the hood and see what's going on. And you'll have someone there who has read through the leaked Claude code, source code, and we're able to explain, they're just using abstract syntax trees and these open source tools, and then there's an LLM somewhere that knits it all together. Mm-hmm. And I think you'll be able to have that deeper understanding. I think Defcon will probably look reasonably similar, actually. But obviously, there'll be lots more technology flying around, and I reckon its token spend can only go up.
oh yeah, it's definitely going to go up. But would you encourage, like, some of the younger folks that go to start with something they vibe coded, submit it to the community to have them build on it in the future? Like, would you push for something?
I think so. I think I learned a lot from reading code. I think I learned more initially from reading code than I did from writing at the very start, and then implementing what I saw in one code base into another one. I think that we're never going to lose that kind of curiosity of how we can build more. And there's always a wall. Like, the ideas get more important the less you have to worry about code. I think you've had a similar experience, Vic.
Yeah, I mean, ultimately, I think Defcon and spaces like Defcon, I think, will become more and more important, and that's especially to convene those ideas and those questions. Because I mean, I personally don't have an answer, and when you asked me, I was like, oh gosh, I'm so head down into quantum. It's kind of nice, just hiding out there. But even now, you're seeing, I think, I can't remember the company that's been making improvements on RSA deployments with using an AI model, I think on top of Google, and they've got like a bounty. I want to say they're out of, where is it? I think on the West Coast somewhere. And you can see that it's not the expertise isn't coming necessarily like in-house from Google or the big, quantum companies. It is like independent researchers that are able to band together. And that's incredibly empowering. It's also a little bit scary that it shows that, with an LLM and a bit of a precocious attitude, like, that there's a lot that can be achieved. So on the one hand, there is this idea like, oh, it's pointless, like, let's just submit and get our UBI check. And on the other hand, there's people going, hey, we can do things we never could. So, I think that's the sort of almost question of our lifetime a little bit, is how do we balance ourselves with these machines and the agency that we want? And actually, for me, things like, embodied intelligence or robotics, that for me is where I'm going, oof, I don't know how I feel about that. Like, am I going to be sharing a sidewalk or a pavement, in a few years with a humanoid? Like, what's going on there? And I think even using those physical issues, I think that's also a good starting point, because actually a lot of people use the human world, and that's why we're building these machines to navigate the human world, because that's where they can be sort of cost effective and useful. And I think that's where everyday people, you don't necessarily need to be a technologist. You should be thinking about what is that future we want? Because otherwise, I think with all these like complex, large LLMs, even myself, there is an element going like, I don't know. But then, a study will come out and say, hey, you can actually see when something's been written by an LLM versus the way it's written by a human. But obviously, if I had an AI company now, I'd go, okay, let's train to figure out how to mimic that, right? And I think, things like people writing is a really important skill. I'm not a really strong coder, so perhaps I'm one of the secret people going, yes, now I don't need to be beholden to an engineering team. I can just get an MVP out. Like for me, I'm like, I wish this happened 20 years ago, that sort of feeling, back to what you're saying, Konstantinos, about, the PQC stuff. So, no, I think it's more that these spaces of convening people and those human interactions become more important. I think I saw some chart earlier today saying I think like 50% of LinkedIn content is AI generated. And actually, if you are a native English speaker and you're reading some of the LLM stuff, you really can start spotting it, and I imagine it's the same in other languages. And it can drive you a little bit insane when I'm like, no, I like reading good writers. I like to improve my command of language as well. It's not just about sucking out the information and the data points. But yeah.
So much to say about that. Yeah, that pangram is being used by everyone around at the tech, like who's writing what. It's difficult to defeat. And speaking of writing and human writing, I wanted to be able to give you guys a little acknowledgement here, in addition to in print eventually. So last year, of course, you guys put me on the creator stage. That post-quantum panic talk went kind of viral, right? And
yes.
And as a result, Wiley reached out to me and gave me a book deal. And next World Quantum Day, post-quantum panic will be a book. So
congratulations!
That's awesome.
It's amazing.
That gives us faith in human curation, because you are our flagship creator talk, our one and only. So,
So despite my little joke
huge congrats
about not sleeping, I appreciate last year's talk and the 2 stages I'm getting this year. I really
well, then we expect 3 book deals now.
We're going for the trilogy.
Yeah. So I'll be talking about what happens on Q Day, the early days, what that might actually look like, what the first attacks will look like. And I'll be talking about, I might be poking fun at a much more successful podcaster with a similar haircut to me and what he said about quantum and how quantum and AI actually really will work together. So those will be the 2 basic topics. Did you guys want to share any others that you know of for the village, or is it still?
I don't know, Mark. Is there anything that we can hint at?
We're very interactive this year. We've got some amazing groups, educators, students, people who are just curious, coming to volunteer their time very kindly. We thank them deeply. To make it interactive, we want people building quantum things this year at Defcon. And if you build them just right, maybe you can keep some of them. We also want to have what else are we doing? We're also having some really interesting talks about different ways of understanding quantum. So some very, shall I say, flashy new ways of understanding qubits. I won't say more than that. Okay, I have to come along and see.
And even threats to quantum computers. They're vulnerable too. Like don't feel like they're just like a one-way threat.
QPUs are computers too, so we've got a whole opening for really analyzing like the deeper threat model of quantum computing itself, answering some what are becoming slightly wider industry questions about what can be read where, what little chirps can be detected by little antennas deftly placed. So we have some really interesting ideas there coming in, which we're working with other villages on. We're bringing other expertise groups into it. As well as, all the stuff that you need to really understand quantum tech if you're not a physicist. Like, I'm not a physicist, neither is Victoria. We love physicists. We love you, Konstantinos. We think that actually but then we also want people to go, okay, how much quantum? And that's what we think is the most interesting question. How much quantum do you need? And we think we're starting to find some ways to answer that. So if you want to come and explore all of those themes and more, please do come to Quantum Village at Defcon.
Yeah, and we also welcome like any volunteers, of all levels of experience and expertise. I think that's the really core tenet, is so many different skill sets and different sort of types of knowledge exchange. And we'll have, educators who are physics professors, and then people who are on the security side. And it's that cross-pollination where everyone's kind of learning something different, having fun, and also giving back and helping other people on their journey around quantum technologies. I think that's when we talk about agency, it's also like, how do you learn in your manner? You don't need to just do the sort of typical course that everyone's doing. Like, actually, you become more powerful if you do it around your own intuition, your own interests. And even if you can't make it to Defcon in Las Vegas, it's not accessible to everyone. We do pop up at some of the B-sides events, and if you're like, hey, I want a quantum village here, you can reach out to us and we can either teach you how to do it or work with you. Or we usually have people, I think we've been going long enough, there's usually someone somewhere dotted around the globe, which is really nice. And just also think about going to other events where you can connect with professionals in your area that are looking at these emerging technologies as well, because I think that in-person interaction is probably needed more than ever.
Continue on. We also have the ongoing project that is Uncut Gem. That was just released one. We actually have, if you have expertise you think would help, sort of improve an open source sensor design, then we'd love to hear from you. We've got a long list of to-dos from various students who have been working on this. So we are coming up for V2 of Uncut Gem.
Ooh, very exciting. And I was going to say, just don't go calling something else Quantum Village, because Victoria will come after you without a smile on her face. So you're welcome to come and join the fun, but don't do that. Okay.
Having said that, we had a group in Argentina that we work with, and it's always like a sister group that they run. And when you talk about agency, it's also not about us necessarily controlling like our remit. We're very like mindful that you've then got to create your own experience and be sensitive to what your kind of space needs, your community needs. And so we're really open to collaboration. I think that's always been the key, like, core tenet. And harking back to what Mark did last week, he did a keynote in Geneva, which was on access and really showing people and demonstrating people from all parts of the world, like, kind of what can be done and what we're doing and how people can start getting involved and thinking about access for what that means for them, because everyone's got different needs. I think that's the big thing about the agency question, right? It's kind of also like, what do you actually need and what do you want in your future? And then you can start thinking about sort of AI for quantum or quantum for AI or whatever the latest buzzword is.
I'll definitely be mentioning that.
Yeah.
So yeah, all this sounds like fun. You know where to go. At the biggest building in Las Vegas. I don't know. I think it is. And there's going to be information, of course, in the show notes. And to echo back on Mark's sentiment, I love you guys, my friends. I cannot wait to see you very soon. We'll all be together.
Likewise.
It'll be a great time. Thanks.
Come and have some fun in Vegas. Let's go.
That does it for this episode. Thanks to Mark Carney and Victoria Kumran for joining us to discuss Defcon's Quantum Village. And thank you for listening. If you enjoyed the show, please subscribe to Pertivity's The Post-Quantum World, and maybe leave a review to help others find us. Be sure to follow me on all socials at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Pertivity. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out pertivity.com or follow Pertivity Tech on X and LinkedIn. Until next time, be kind and stay quantum curious.